actually analyse what we've got here. This is the basic preamp board, and this is actually a stabilised power supply because there are no on-board power supply connections with this board. It needs plus and minus 15 volts DC, and these capacitors here are just basically decoupling. You do need to have a stabilised supply going in here, and that's what basically this board is. This was another kit that I reviewed a couple of years ago, and it's just basically transformer goes in here, and it's a standard. In fact, I used exactly the same transformer that I used in the previous video, which puts out 15-0-15. I've just not put it on this. I shall have to go and get it in a minute because obviously it needs power to work. So forget about that. That does not come with a kit. In terms of value for money, this is actually quite an expensive kit as kits go. When I'm saying kit, I've already told you that it is not available as a kit. But this PCB you buy as seen, with or without a potentiometer. Now I bought it without a pot, and I've put this pot on here temporary. It does say a 50k pot, but in this case I'm actually using a 20k pot, and it's a logarithmic, of course. Standard input here. A circuit diagram of sorts is included. If you look at the advertisement, which I'll put up in a moment, it does show you a circuit diagram. On closer examination and a very quick reverse engineering, the circuit board here does not correspond to the circuits supplied. Whether that's done intentionally, I don't know. Once again, for people that like circuits that are very simple, they won't like this board at all because it's quite complex insofar as you have FET inputs and these dual inline circuits, as well as the obligatory 5532, can't remember if it's the 5532 or 5534. This op amp here has been filed, and I don't know what that is. You can clearly, well, you can clearly see that it's been filed, but I don't know what that chip is. These two here are genuine, but as I don't know what that is, I don't know if it's genuine or not. I don't propose to go into much detail for the circuitry, particularly as it's not a kit, so if you want to mess with it you can. The main thing is to show you what it's like and should you buy it. I think for the moment that's all I'm going to say about the actual board, other than the fact when it arrived the back was covered in flux or other stuff, and it took a hell of a lot of effort on my part to remove it, which I think is a bit bad. It wasn't just the usual flux, it was something that really was all over the board, and I wasn't very impressed with that at all. I'm going to connect it up now, connect it to the equipment, and we'll see what it looks like. I want to show you an interesting phenomenon which has been, well, I don't think anyone has ever addressed it, to be honest. What it is the effect a volume potentiometer has on the input of many amplifiers, and I'm going to show you the effect of it on the scope and what I've done to remedy it. But this is a 20 kilohertz square wave coming out of this preamp. Forget about what it looks like as such at the moment. I mean, it looks dreadful compared with the previous preamp, but forget about that. What I'm going to do is this is connected via the volume control, which you can see I'm twiddling right now, and that's off. The noise, by the way, is because I've got very low levels, irrelevant for this demonstration. Look at the square wave. Watch what happens when I increase the level. Look in particular at the rise time. Now look at that. It's a much better square wave, isn't it? I can show you very, very easily how to fix it, and I'm going to show it to you. So you need a bit of a memory, but what I'll do is probably flick between the two on the final edit. So this is unmodified as it comes. Full volume, a reasonable square wave. Don't judge it for anything other than it's reasonable. And as you turn it down, it begins to round off and look pretty gross. Okay? I'm going to switch over to the other channel which I've modified and show you the difference. So remember, in fact I'll leave everything exactly the same. I'll put it up a little bit so it's, and when it comes back it'll be on the other channel which I've modified. That will be the only difference. Right, this is the other channel which I've modified, and I'll show you the modification in a minute. But as you can see, it's completely different, isn't it? And I'll go through the same actions with the pot. I'll go up to full. There you are. That's with the gain on full on the volume control. And I'll turn it down. And just to show you that that is, I'll just change the scope now. You've increased the noise because I've literally only got a few milliwatts, well, millivolts coming out of it at the moment. That's why you couldn't see all that mush. But you can see it's still pretty square, and you know, that's nothing. So I'll change the scope back again. And there you can see. It's virtually the same all the way down. Here's the view of the board, and clearly that's the input with the volume control. This is the component I've changed. Now that was one of these, a 220 picofarad. I'll show you a bit of the circuitry which shows you the component in question. I've removed that capacitor and I've tapped this capacitor in its place. Now this is a 30 picofarad, and that's all that makes the difference. It's clearly not fitted at the moment because I've been experimenting off camera with different values. So that's the other channel. So that's what I was showing you before. One channel had that capacitor on it and the other channel has this capacitor.
What do you think of it so far?
Oh, it's
Rubbish?
rubbish.
Rubbish, I thought it was.
This is the 1K and looks quite nice, but just a tiniest bit of overshoot here, but nothing to worry about. This is a 20 kilohertz square wave, and it's reasonably good rise time. If I expand it a bit, at the other extreme, 10 hertz, which is the sort of shape you'd expect at that frequency. As expected, the frequency response is largely flat, and this is where it just starts to drop off. This is still 0 dB at 50 kilohertz. That's half a dB down at 160 kilohertz. So I think we can say it's flatter than flat. I won't go any higher because we get so many people saying, oh, we don't want to pick up Radio 1. Well, you won't, but this is just what it does. Well, the low end is, as you'd expect, flatter than flat. And the scope's having a trouble syncing here, but that's 3 hertz and it's still 0 dB, which is what you'd expect because it's a DC coupled amplifier. This is clipping. You can just see it's clipping at the bottom, and it's very slightly not symmetrical. But saying that, That's 10 volts RMS, and in the real world virtually no amplifier needs that kind of input. If we take it down a little bit, that's now giving, well, that's just under 10 volts, and you can see it's completely clean. There's not a hint of anything on the waveform at all. Not a bad preamp, reasonable gain, very high output level should you require it, low noise. On the negative side, I did manage to find out what that elusive IC was by wetting it and shining a torch at a strange angle and looking at it with a high power magnifying glass, and I think, but don't quote me on this, I think it is a Texas Instruments LF353P, and it's classed as a wideband JFET dual op amp and is primarily made for professional audio mixers and in D to A analog preamps basically. So it's fairly fitted for what it is, but why they should want you not to know that, I don't know. Now the other negative side of this preamp is, first of all, you can't build it yourself, so you pay the higher price. And the other issue is most of the semiconductors on it, excluding the one I've just mentioned, are pretty well obsolete, and if you have to get any of those special effects, should one fail, I know it's unlikely to be fair, but you may have trouble getting those components. The other point is you will need an external stabilized supply for it, because you have to put in plus and minus 15 volts DC. So you could see from my little test setup there, you do in fact have to buy or build a 15 volt dual power supply. Low current, and you can, of course you need to feed that with 0.15 or thereabouts transformer. So when you add that to the already 36 New Zealand dollars for the basic kit, the price does fluctuate quite a bit. So look around, and if you want to buy one, just look for a good price. Often they're post free as well, which is a bonus. But I would ask you, why would you choose this particular one? Oh, the price, by the way, I gave you was for the basic unit. If you want the Alps pot to go on the front of that, it then costs $46, which is fair enough because the Alps pot is not cheap, but it's worth having if you want a volume pot. Well, you will need a volume pot. And like most of these boards, you will have to modify the little capacitor that I told you. I think from memory they were 220 picofarad, although it does say on the board 270 picofarad, and I've replaced it with a 30 picofarad. I've done that simply so that the volume control has virtually no effect on the frequency response. If you put a pot, a 50k pot on there as shown or straight out of the box, you will get a slower rise time, and you will also get limited HF. But if you're one of these people that think that a bandwidth of 20k, a couple of dB down is fine, leave it. You're happy and I don't care. What does it sound like? Ron, my colleague in America, he's categoric that he doesn't like the sound of it at all, but he was testing it with headphones, and of course a headphone is much more critical than feeding it into a power amplifier and a loudspeaker. But I haven't done that because I don't have a good pair of headphones that I could make a suitable comparison on. But certainly when plugged into any of the amplifiers that we've talked of late, the L12 or the Accuphase clone, I found it sounded fine. If you're in the market for a preamp, just use the Accuphase because it's a quarter of the price, and certainly on paper, even because measuring things isn't opinion. If one measures better than the other, then it's better. We're talking about very fine limits now, where you listen for hours and you hear a slight difference. So don't get me wrong, if you want to buy this, because it's, well, dare I say, very loosely based on a Sugden preamp in one of their DACs. You can go onto their website and read all the propaganda if you want, but if you just want a really nice preamp, go for the Accuphase clone, which is a quarter of the price, and at least on paper and I think in both of our opinions, it's a more neutral sounding preamp. I wasn't going to actually publish this particular preamp because it seemed a bit pointless reviewing a product that we don't really recommend. But saying that, we're not recommending it because it's no good. We're not recommending it because why would you spend 3 or 4 times the price and you've got to put a extra stabilized supply on it when the Accuphase even just out of the box works well? But with a couple of mods, if you look back at the reviews and videos that I made of it, you can turn it into a really, really good preamp. Thank you for watching.